Computer science. So in today's class, I am going to take it one step ahead. So starting from paper 2, chapter number 7, I already sent the PowerPoint representation to you. Let's first take a recap of what we discussed in the last class. Then we are going to go ahead. So in this first chapter of paper 2, we started the discussion with the program development life cycle. The life cycle means the stages of maybe a human, or if it is the program development life cycle, that means that it is the stages of the program development life cycle. That means that if you want to create a piece of software or if you want to program, so there is some series of steps or some series of stages that you have to go through. So creating software is not like done overnight, that you just started coding and yet it's done. So some of the important areas for the program development lifecycle is analysis, design, coding, and testing. In the analysis part, I discussed with you that whenever you create a soft piece of software, whenever you wishes to create a piece of program, you try to solve a problem. So in the analysis part, what you do is that even before solving that problem, or even before creating the software, first of all, you need to know the purpose, that what you are creating the software for. What is the reason, right? What is the reason? You need to do your analysis, that even before the problem can be solved, it needs to be clearly defined out so that you can work on your solution. In your analysis part, you have two important areas. One is abstraction, the another one is decomposition. So both of them are the tools that we use in your analysis part. So in analysis, we use abstraction, and we use abstraction to keep the key elements required for the solution of the problem. That means that we only need the key elements, that's it. It means that you are discarding any unnecessary details, or you are discarding any unnecessary information that is not required. So for example, you have a map. So in a map, you can see, like, if you are traveling from one place to another, you are not going to stop at every place. You just have your target destination, and you just have the place where you want to go. So this is abstraction. Abstraction means कि रास्ते में जितनी भी चीजें आ रही हैं, आपने सब इग्नोर कर दी, आपने सब एलिमिनेट कर दी. You are just focusing on what you require. The second thing is the decomposition. Decomposition is कि जब आप किसी भी चीज को अपने स्मॉलर एंड स्मॉलर पार्ट्स के अंदर ब्रेक डाउन करते हो, ताकि वो आसानी से सॉल्व हो जाए. अच्छा जी, फिर हम आए थे डिज़ाइन के ऊपर. इन डिज़ाइन आई सेट के हम आज की क्लास के अंदर ये डिस्कस करेंगे कि डिज़ाइन के जो थ्री स्टेजेस हैं, स्ट्रक्चर चार्ट, फ्लो चार्ट और सूडो कोड, हाउ वी वर्क एंड हाउ वी सॉल्व देम. So, and then the fourth part is the coding and iterative testing. Coding and iterative testing is the final phase. Here, you are requested to create your piece of program. Means you need to develop your program. Then you need to select the programming language that is most suited to you. In the testing part, this one is like to make sure that your program is running with different set of data. So if I summarize this, after in program development life cycle, first of all, I have analysis. In analysis, I have decomposition and abstraction. Abstraction is eliminating unnecessary information. Decomposition is breakdown of elements. After that, you have design part. In design part, you start designing your piece of code into three parts: structure chart, flow chart, and pseudocode. Like, you are designing it, how to implement that. Then the third part is the coding. Coding means that when you have the design and when you have the draft ready and prepared, you start working onto that piece of draft. And then you have testing or testing and iterative testing. Iterative, the word iterative means repetition. So iterative testing means repeatedly testing, which means that you are repeating the test or something again and again repeatedly for a number of times. So this is it. Now in your design part, you have structure chart, flow chart, and pseudocode. So Let me show you an example. Like right here, right in front of you is an example of a structure chart. Now, I'm going to ask each one of you that what is your analysis regarding this structure diagram. So you can open up your mic and you can speak, like just tell me that what this structure chart is showing to you. Do you have any observations here or any feedback?
Decomposition.
Yes, excellent, excellent. That's an excellent answer. Decomposition, excellent, because you can see that it is being breaking down into a number of stages. Up in your paper, if you are asked about decomposition, if you are asked about structure diagrams, or if you are asked about top-down design program, so they are mostly the same because they are reflecting the same concept. Top down design program or anything that is in a hierarchy. So hierarchy means, like, if I give you an example of a hierarchy, so in your school you're going to have principal, then you're going to have your supervisor, then you're going to have your coordinators, then you're going to have your teachers, then you are going to have your students, right? So this is basically a hierarchy. So in your structure diagram, the point is that it is showing a top-down design program, which means that it's starting from top and it's going till the bottom. This shows you a hierarchy. Hierarchy means which one is first in the order. So you can see that how a computer system is being divided and furthermore being subdivided into more and more systems. So if necessary, you can even divide them further as well. So this is your structure diagram. Like right here, this is an example of an alarm app. So you can see yourself that this works in the design perspective that for me, I only have one application. Like, what is my application? What is my purpose? What do you want to create? Sir, I want to create an alarm application. But into this alarm application, you can see that you have like so many areas, like, right, like you have the option to set alarm, you have the option to check alarm, you have the option to sound alarm, and then within those, if you want to set alarm, that means you want to set it. If you want to turn the alarm on and off, then you have also the same area. Then for the sound alarm, you have these features. So you can see that this is a structure diagram. It is showing you decomposition. It's breaking down your larger part of problem into a smaller problem so that it can be solved. The reason is that when you have this part and when you break it down it into three steps and you furthermore break it down, then after that you create a piece of code for each and every module. This each box is known as a module. So you create a code for this module, you create a code for this module, you create a code for this module, this module, this module, this module, this module, this module. That means that you create the piece of code for all of them, and in the end, you integrate all of them into one application that is known as your alarm app. So are you getting the point?
Jesus.
So in a structure diagram, you have modules, right? It can be known as decomposition, and or maybe you can call them as a top-down design program or a hierarchical program. So do you have any paper or pen, anything right in front of you?
Yes.
So I'm sharing with you one example question from the past paper of the structure chart, and I want you to give it a try. So this is your question. So what you need to do is that you need to solve this and then you need to submit me your answers on the WhatsApp group so that I'll check and give you the exact answer. This is the question. You need to complete this structure diagram. Just give it a try. structure. So I'm sharing the answer right here. This is question number 5. So this is going to be the exact answer for this. The question says that we have a food ordering system now. It says into the question that allow the users to enter the details of the food they want to order and if they want to pay for the order. So the same you have to do in this. So first of all, you have the food ordering system, then you go for the food input. Then it says in the question that allow the user to enter the details of the food as they want to order and pay for the food. So if they want to order, if they want to payment, or if they want to display their choices, then it says that display the food available as a picture or a list. So display option, picture and list. So that's it. So the answer that I have right here is here. That is food order, food display, payment, and picture and price. So this is also correct. Mr. Shayan, your answer is correct. So I'm just trying to show you that you can have the similar types of questions in your exam for the structure diagram. Now, another important thing that we have to discuss right here is regarding this. Like, for example, you can have into your exam a question that what is a computer system? So you can write into your exam that what is a computer system? A computer system is made up of software, data, hardware, communication, and people. And then each computer system is subdivided into subdivided into subsystems, and each subsystem can be further subdivided into subsystems until it performs a specific action. So this also refers to the same concept of the structure chart, that you have subsystems that are being divided into subsystems and until you reach to a solution. As I discussed earlier, that the computer programs and systems can be very large or very small, and it's not like if you want to create a piece of software is going to be it takes a lot of time. You need to break it down. You need to decompose your task so that you can work onto it. Another thing that we have discussed right here is that in order to understand how a computer system or a program is built up or how it is work, it is divided into subsystems. You can call it subsystems or you can call it the module. The division can be shown using the top-down design approach to produce a structure diagram that explains that how it works. So each subsystems can then be divided and then you can work on the each module separately. Top-down design, we have already talked about this. This is the decomposition of a computer system into subsystems, breaking down your problem into smaller and smaller areas. There can be a question into your exam that why do you need decomposition or why it is important. So you can write this down that this is basically an effective way of designing a computer system to provide a solution to a problem, because when you break down your problem into many smaller and smaller tasks, it becomes more manageable. So this process is known as the process of breaking down subsystems is also called stepwise refinement. Yes. Stepwise refinement means that now you have all of the modules broken into stepwise. Some important keywords that are important for your exam, I'm writing it right here. It's top-down design approach, then it's abstraction, it's decomposition, it's structure charts, then it's stepwise refinements, and what else? Subsystems, modules. They can ask why, how, why is it important? So you can answer it that they are important because when you break down your problems, it becomes more manageable, it becomes more easy. This structured approach also works like for the development of the both larger and smaller computer systems. Another question in exam there is that states that if you want to decompose a problem, so a module is known as this. This is a module. You can call it module, you can call it subsystem. All of these are known as a module. So there's another question in your exam that says that how can you decompose a problem? So if you want to decompose a problem, it means like breaking it down or creating a piece of software, you need to follow four different stages. First is input, then you have is your processes, then you have is your output, then you have is your storage. These are the four areas that are important when you are decomposing a problem. So input is basically like when you are creating or decomposing a problem, what is going to be the data that is going to be used by the system that needs to be entered when your system is active, which means what data has to be entered. Process means that what operation you are trying to perform with that data. Output means that the information that needs to be displayed or printed. Then you have the storage part. Storage is like the data that will be stored, like what storage devices you will be using, either primary or secondary, hard disk drive, solid state drive. So these four stages are important when you want to decompose a problem. Other than that, the next area that I have right here is flowcharts. So what is flowcharts? Can you give me an example? Anything that comes into your mind? What is a flowchart? Can anyone of you tell me what is a flowchart? So you can use flowchart to show diagrammatically, graphically representation. Like if you ever go into a building or a school, just as you enter on the right hand side, you basically have something like a map of the building that really showcases you that if you want to go onto this section, you should be going through this. If you want to go here, you can go this. So this is basically an example of a flow chart. A flow chart is the one that gives you the correct way, or they gave you the correct representation of data, or if you want to have a more better approach, or if you want to tell someone that how this process will work. If you are studying chemistry, then you have seen these types of charts to see that how the things work with each other. So we have the same approach in computer science as well, that if you want to show someone that how the steps are being completed or what is required to complete a program, or what order a flowchart has to be operation that has to perform, so we use a flowchart. So these steps are basically the reflection of an algorithm. So you convert an algorithm into a flowchart to help explain your manager or your company or your team that this is how it will work. So this is an example of a flowchart. Like you start the process, you get time means anything you inputs here. Then if your time is equals to time alarm, that means it will sound it. But just in case if it not sound, then you need to wait for 30 seconds. Then you have the shapes of that you need to remember, and then the flow lines. So I'm sending these shapes onto the WhatsApp group, so you can go through them. So these shapes will be important when you will be solving a flowchart, or when you will be creating a piece of flowchart instructions. So I have sent them on the WhatsApp. Now, the next part is an example question of flowchart that I don't think so we can do right now. but we will start the example question of flowcharts in the next class. So meanwhile, you can go through everything we have done